guys, we're still doing limits of functions. I'm doing the last example using the tree approach that we discussed on the first session. So without wasting time, guys, let us go through it. But remember, as I said, this is limits of functions for calculus 1, cal 1. So yes, now let us approach or let us see this type of a limit of function. Now I was requested to do a different one because apparently the first two ones were easy, but it defeats the idea if I don't show you the ideas themselves. Okay, so this one was chosen, and let us go through it and see how we can go about it. So we have the solution. Okay, this time I'm gonna write the tabular method with a different pen because that one, it takes a lot of space. Now we're gonna do the same thing. So you know what I usually like to do, guys. Just put wherever there is x, I put brackets divided by the square root of x plus 1, and then everything minus 1. Now we are going to have values of x and see the corresponding y values. Okay, so let's put those values of x. So as I said, you always take values of x which are relatively close. So let me take from 0.2, negative 0.1. Our x is 0 this time, guys. Please take note of that, okay? And have negative 0.01, negative 0.001. Okay, so we're gonna do the same thing, substitute all the values that we have. So we have negative 0.2, sorry, and then we need to have negative 0.2. So the first value we get is 1.89. So we have 1.89. Okay, so let us put negative 0.1, negative 0.1, we get 1.95. 1.95. Okay, so let us look at negative 0.01, negative 0.01, 1.99. Wow, 1.99. So let us look at 0.001, negative 0.001, 1.999. Okay, 1.999. Okay, so we see that as we put this into two decimal places, it's going to be equals to 2. Now this was the approach from the left of 0. Okay, and then wrote 0 straight. Now let us have the approach from the right, x and the corresponding values of y. Now we're going to look at it from the right, so we're going to have 0.0001, and then have 0.001, 0.01, 1.1, and then let's have 1.2 for the sake of I was thinking of 1. sorry, I was thinking of 1. It's actually here, should be 0.1, 0.2, 0.1, and then 0.2. Sorry, I was thinking of 1. You see, doing most examples of 1. Okay, so let us approach. Let us see now 0.001. Looking at the positives now. Get 2.00. 2.00. Let's look at 0.001. Got 2 zeros now. 2.00. Okay. Let's look at when we have 1 0. We get 2.00. Okay. 0.005. Okay, it doesn't matter actually. And let's look at 0.1 now, guys. Okay, let's look at 0.1. We get 2.05. Let's look at 0.2. 0.2, we get 2.0, okay, 2.10, okay, when we have that into two decimal places. Now, this is from the right of 0. Okay, there I nearly made a mistake when I put 1.1. Hey, now look at this, guys. When the values of x are approaching 0 from the left, the values of y are approaching 2. When the values of x approaches 0 from the right, the values of y are approaching 2 from the right as well. Okay, so thus we can say that therefore the limit as x approaches 0 of x, square root of x plus 1 minus 1, it's equals to a 2. Okay, now let us look at the second approach, the graphing one. So let me determine the space as early as possible. Or now this is the second method, and the second method is the graphical approach. Okay, so the graphical approach, we are going to have a function, right? This function is going to look something like this, and then let us have a point here, because it has -1 and +1, so it's gonna start here and move like this, and the point of intersection here is going to be 0 and 2. It's going to be 0 and 2. Okay, now the function that we're looking at here is a function of y is equals to the square root of x plus 1 plus 1. Okay, now what type of a function, where do we get this type of a function? We get it as the inverse function of a parabolic graph. Inverse function of a parabolic graph. This plus 1 that we have here, it means that it has shifted 1 unit to the left, and this one means it has shifted 1 unit up. That's why we have a function that starts here. Okay, so how you look at the functions really plays an important role. Okay, but if you can check, all the graphs we have drawn, they come from the greater of knowledge we have. Okay, now when the values of x are approaching 0 from this side and the values of x are approaching 0 from this side, the values of y from the left is approaching 2, the values of y from the right is approaching 2. Then therefore the limit as x approaches 0 of x square root of x plus 1 minus 1 is equals to a 2. Okay, now let us look at the third one, the one you like most. Now we will have the limit as x approaches 0 of x over the square root of x plus 1 minus 1. So we're gonna introduce the third conjugate, the conjugate. So the conjugate, let us write this for now, multiplied by the square root of x plus 1 all over the square root of x plus 1 plus 1. So this is just multiplying by 1. Okay, so we're gonna have the limit as x approaches 0, this times that is just x multiplied by the square root of x plus 1 plus 1. Okay, yeah, so this is just a difference of two squares, so this squared is just going to give us x plus 1, and then this times that is just going to give us minus 1. So this and that, they give us 0, and then we'll have what? The limit as x approaches 0 of x, and have the square root of x plus 1 divided by x. So this and that, they give us 1. Then we have the limit as x approaches 0 of the square root of x plus 1, which is when you put 1 here, it becomes 0 plus 1. So the square root of 0 plus 1 is just 1, plus 1 is just equals to 2. Okay, so the 3 approaches that we have for limits for limits of functions are always going to hold. Okay, so you choose any approach that you want. If you need more examples on this, please do let me know. For now, guys, if you came this far with the video, please hit the like button, please subscribe, guys, and please share the video, as it helps with the algorithm of recommendation for other students as well. For now, guys, please do check the information for our email address, our Facebook page, our Instagram page. We're also available on Twitter. And without wasting any more of your time, guys, thank you very much. See you on the next one.